Hello guys, today we are going to learn about product review sentiment analysis using the BERT model in Python. And first of all, we are going to start with the introduction to NLP and sentiment analysis, and we are going to move forward to importing data cleaning and pre-processing, followed by training and testing. Alright, so NLP and sentiment analysis. Well, let's get started with NLP. Natural language processing means making the computer understand the semantics of text so that it develops some sort of understanding and it can, process it like a human being. It is also about giving the computer ability to interpret and understand context of data. Now, for this purpose, the computer has to look at a lot of data at the same time, and it has to keep track of what was happening before so that it makes sense of the context that we are talking about here. Whereas sentiment analysis is telling whether the text data contains some emotion, if it has any opinion or any emotions, and it does by classifying it a number, 1, 0, 1, where 1 means positive and 0 stands for negative. It could also be neutral in some cases. In some sentiment analysis, the computer also returns a value for neutral responses. Now let's move on to the hand-on practice that we're going to do, and we're going to start by installing some libraries and dependencies. Then we are going to load our data set and start with its pre-processing. After that, we're going to convert it into some tokens using the BERT model that we will be using throughout this example. And then we are going to train our model and perform some optimizations. At the end, we'll do some evaluations and conclusions. We'll give it a test sentence and look if it can determine whether it's positive or negative. Alright, so let's move forward to the library, the development environment that we have, that is Python, and we're going to use Google Colab for this purpose. Now Google Colab is really good when we are just installing. We don't need to install most of the libraries. It comes pretty much installed, and you don't have to create any environments or you don't have to get in a lot of trouble. You just straight ahead go ahead and start importing stuff. So for the libraries that I have imported, I'm going to run all of these commands that you're going to write, and we're going to talk about them one by one as they come along the way. Because since we don't have the transformers enabled in our library here, so we need to install them. So we do that by a pip install transformers. All right. So this will take a while. It's going to go into Python and install the transformers library that will be used at the backend of BERT. Alright, so now we can import all these libraries that we have, and it's the BERT Tokenizer, which converts all the data into tokens. And let me just check if the runtime is GPU. Alright, see. Alright, so, and then we have different libraries that we are going to import. Let me just import them because they take a while sometimes, and it's going to download the data for us. Alright, so transformers we are talking about, they are just something very that can help us determine our text into tokens very easily. And the BERT models have replaced conventional LSTMs and RNN networks which suffered from information loss in large sequential data. They can easily understand the context of a word in a sentence based on previous words in the sentence due to its bidirectional approach. The advancements in the hardware made it possible for models like BERT to be built as required, so that we can use it for even for computer vision problems as well as the text data problems. And TensorFlow is a popular and widely used machine learning framework for developing deep learning applications. We've just imported TensorFlow here, right? And this line actually checks the number of GPUs that are available for us, since most of the transformers will run on GPUs. Then we are going to download a list of stop words, and these stop words are actually words that appear very frequently in our data. For example, is, am, are, the. These, if we remove these words, they won't make a lot of sense to us humans. But for computers, they don't really make much sense, and they can interpret data even without the presence of these words. So these are called stop words, and we are going to use NLTK, which is another very popular library, to get rid of these stop words, right? So that was about the importing libraries. Alright, so let's talk about the dataset. The dataset that we have here is the Amazon Review Mobile Electronics Volume 1, right? So this data is already available at this URL. You can just go here and check it out and check out about this dataset, what it really is, and we can import the dataset into our data frames, right? And you can do that by doing the df equals df ds dot as data frame and pass ds here, which was the variable that we are storing here, right here, right? And this will take a while so that we can discuss our dataset, right? So if you go to this URL that as we were talking before, you can just, as I've already opened it here, you can go here, and this is the mobile electronics dataset that we have. These are the column names that we have here, right? There are about 11 columns, and different columns tell us about different things. For example, we have product ID, product category, and then we have the review, the text data, right? For example, this review tells us that it's not working, right? And just like that, we have another review here which is quite long, right? And it seems to be positive because it says it tells us about the product and it has the word great in it, right? So NLP means giving computers the ability to judge whether these reviews are, either they're positive or negative, right? Alright, so we have just we have loaded our dataset, right? And to print it out, we converted it into a data frame, and here is the head of that data frame, the first four rows that I just showed you here at the website, and now we have them here with us in our data frame in our Python notebook, right? So now we're going to do some pre-processing, and we're going to run this cell here. What it really does is it just converts the let me just run this again. Yep. So it just converts the the star rating column that we have here, here is the star rating column. It says that if it's 1, if it's greater than 3, give it a positive review. For example, 4, 5, 5, these ratings are positive, right? So they're going to get positive in another column, which is called sentiment. And if it's less than 3, give it a negative. And they are just for this sentiment column, we are going to give 1 for positive values and 0 for negative values. Then we're going to convert it into this in this format in the UTF-8, and now our data frame becomes a smaller data frame which has just 2 columns with us. Alright, so just this is going to take a little while. In the meantime, we have our data frame, and to print this data frame we'll just dot head and 4 here. Right, so the first 4 rows have a short review and their corresponding sentiments. Alright, so now we're going to remove some layers at the end because we need a smaller data set for our validation data. So the tail function actually reduces index equals true, keeping the index. The tail function actually removes the last index, the last these much rows, right? And it keeps the rest of the data frame as it is, and keeps the index in place. And we're going to say index, not index, comma in place equals true. Right, so we just shortened our data set into smaller data frame. So now we're going to take the reviews column that we just short reviews, and what we're going to do is take the values and make them lists, right? And we're going to do the same with labels equal TF sentiment, and we're going to make them to list. So now that most of our data set has been turned into lists from and then we are going to import this built-in function called the train test split. I think, yeah. And we're going to take this function and training sentences and into validation sentences. First we have validation the S is smaller here and we'll move on to training labels, right? And training labels and validation labels. Alright, so we're going to use the split and train test split function, and we're going to pass it our reviews and labels, right? And we're going to pass these labels as well as a test size, which is going to be 0.2, right? So in this way we have split our test into two different sets. with their corresponding labels. So now we have tokenizer, and it is going to be distill tokenizer fast. We have imported it before from the from pre-trained, and we're going to pass it into the BERT function that we have, which is the distill BERT and base uncased, right? Right, so that's about the tokenizer. Now the tokenizer is going to convert each and every word into some data type that the BERT model actually understands. So we have tokenizer and tokenizer, and we have we'll just use the training sentences, and we're going to use the first one of it and give it some truncation equals true, as well as padding equals true, as well as we provide a max length, which we're going to set to 128, right? So that was the setting of the tokenizer. We'll take the train encodings, and these are all built-in functions. So you see how helpful BERT is with the help of Python. It just it reduces most of our work into just smaller functions, and you just have to set these parameters and your work is done. So it's just amazing how quickly you can do it, right? And we're going to just copy it here and use the validation val encodings variable, right, and pass the validation. Alright, so these are all the encodings that we're going to get. So it will take a while. Meanwhile, we can set our train data set equals tf dot data set, and we can just dot from tensor slices, since we have just used different tensor slices to convert our data into tensor slices. We are just going to make a dictionary out of it and stitch together all of the train encodings, right, and their labels, comma, training labels, training labels. So it's labs here, so you can just think of it as training labels, right? And we just run that code. You can copy it for validation dataset. I can just use the val dataset here. You just change the train encodings into val encodings, right, and the training labels will be converted to validation labels, these labels here, and you run this as well. All right, so now that we have all of our training and training set as well as the validation set, both of them are ready, we can download our model here, which I've already done because it takes a lot of time, and we set different parameters here, such as using the optimizers, which is Adam, and set learning rates and epsilon. So after setting all these parameters, you can compile the model and begin its training. So you see how we took raw data, we pre-processed it, we removed all the useless columns from it, and we moved on. We calculated different stuff, we just cleaned it, and you know how we just set it according to the requirements of BERT, right? So the simple is that. And so I'll just stop it here because I've already done it, so I can just stop it. I can just show you how this will end up. And we have this, so we set these different parameters, right? And we have all the models that we have. So we can just, you know, take the model, and it's going to get trained here, right? We just pass it different functions, and we test it here. After it's trained, we pass this training function. We take the test sentence and do all the pre-processing on it, remove the padding and truncations, and use it to predict inside our model. And we pass it here. We get the let me remove this. We get the label, which is negative here, since the sentence, the review is, this is a bad product and I really hate it. So if I do it, this is a good product and I really love it. So it's going to change because it's positive now, because that is what sentiment analysis is supposed to do. So that was sentiment analysis on our text data, particularly the product reviews, and hope you enjoyed it, hope you learned something new. And if you want to support us, please subscribe our channel and like this video, share it with your friends, and keep visiting our channel. Hope to see you in the next video.